And as you can see, we are not ever spawning 2 octopuses in a row. Very good. Hi, I'm Ricky. Today we're on the 9th episode of the Endless Runner series. And in this episode, we'll take a look on how to implement scaling difficulty to our game. We'll make things go faster with time, and we'll also add more enemies. We'll start the episode with the scaling velocity. Then we'll make a new way to spawn our enemies so it will be easier next time to add more enemies. And finally, we add a new enemy. Okay, so let's start. For the scaling velocity, we'll do all the calculations in our spawn manager. So let's go grab it. In here, we want to add 4 new values. A value to hold the maximum spawn timer max, a value to hold the maximum spawn timer max for when the maximum velocity has been reached, a scaled value for our entity speed, a multiplier value which we'll use to our entity speed and spawn timer max to add or decrease from them, and finally a boolean to tell us whether we have reached maximum velocity or not. Okay, and to make things clearer, I'll also add a header and switch some of the values. Much better. Let's go to the inspector. And here are all the values that we want to change to make our scaling velocity. So spawn timer max will be the initial value of our spawn timer, while scaled spawn timer max will be the final value when we reach maximum difficulty. So I'm gonna set the initial value to 3 seconds and the final one to 0.5. For the entity speed, I'm also gonna set the initial one to a lower value and the maximum one to a bigger one. These are of course very random values, we'll fine tune it later. Okay, let's go back to the script. And in here we want to make a new function to increase the speed, and it's gonna be a private void. In here we want to take spawn timer max and entity speed and increase them or decrease them to point them to the final values. And for the calculations we'll use scaling multiplier. And now let's call this function in the update method. And let's also bring this if-can-spawn-return part to the update method. This way, if we can't spawn an enemy, we also won't increase the speed of the game. Okay, and let's test this first version in Unity. As you can see, the values of spawn timer max and entity speed are decreasing and increasing. And if we increase the scaling multiplier, they're gonna go faster. Of course, there are a lot of problems right now, as you may guess. So the first problem is that the values don't match up perfectly with their counterparts. The second one is that the entities don't update the velocity based on the values that we have in our script. The third one is the scaling multiplier. This value is what holds the script together. Increasing or decreasing this value just by a tiny bit could very well mess up the whole thing. So be sure to always have a value that is just slightly above 1. Okay, so let's go back to our script and start fixing. Okay, so the first problem is really easy. We can just use an else statement and set it to the scaled value. This way, when they go over the requirement, they just match to their counterpart value. Be sure to use the same signs that I'm using. It's very easy to mess up these little things. Finally, let's turn our boolean is maximum velocity reached to true when both of these values are equal to their counterparts. And at the start of the increase speed function, we return if our maximum velocity has been reached. Good. The second problem, we have to update all the entities' speed to the one that we have here. To do that, we'll make an array of all the entities in-game. And we'll search all the entities by tag name. And then for each of the values in our entities in-game array, we'll set the velocity manually. And the code that I'm using here is exactly the same as the one that we use when we spawn an entity. So right here. Okay, so disclaimer, this is very inefficient, but we'll see how to optimize it later on. Okay, but let's test it to see if it actually works. I'm gonna increase the scaling multiplier a bit and hit play. As you can see, the entities have maintained their distance between them, and the values now are set to the right amount. Back in our script, we want to add two more things. The first one is a quick and easy way to add a bit of optimization. This won't be the final product, but it will make things a lot better for the moment. And that is calling our function not every frame like we're doing right now, but every 5 frames. Of course, we can use a coroutine for that, but we can actually use another way that is really a neat trick. So when we check if the maximum velocity is reached, and we return if it is, we also want to add a new condition. What this is doing is reading the current frame in our game, and if it isn't divisible by 5, then we return. Do note that frame count doesn't count from 0 to the 60 frame mark, but it counts the frames from 0 to infinity. So basically it doesn't matter how long we've been playing the game, if we check if the current frame is divisible by 5, then it means that it's been 5 frames from the last time. So instead of calling this function 60 times a second, we'll only call it 12 times a second. This is a quick trick to take a bit off of the load from our computer, or from our cell phone. And next, the final thing I want to add is check whether the time is more than 0. And when I say time, I mean time.timescale. Because as you may have noticed, we are not using time.delta_time in our calculations. We are not using time.delta_time because time.delta_time is very variable, and it could mess up things very quickly. Also, it doesn't really matter if the maximum velocity is reached in half a second more or less than they want to, so it's not really a problem if you don't use time.delta_time. It can be a problem though if we pause the game, because if we pause the game, of course we don't want the speed to increase, but without using time.delta_time, this is what will happen. So in our return condition, we just check if the time scale is not 0. Okay, and now we'll also have to increase a bit our scaling multiplier, but that is a very subjective value that you can change however you prefer. The last thing though, and this is a bit personal, I'd like to keep the initial distance ratio between entities from start to finish. So basically I want to keep the same ratio from spawn timer max and entity speed from when we start to when we reach maximum velocity. To do that, you can use a proportion and see what the right value for scaled entity speed should be, or we can just set this value when we start the game. So in awake, we say that scaled entity speed is equal to spawn timer max divided by scaled spawn timer max times entity speed, which is the proportion expression. So let's test this in the inspector. And I'm gonna use roughly the same values that I've used in my actual game, BoatVenture. And now if we hit play, we should see our scaled entity speed match up to the right ratio. Here it is. If we play the game now, things should go smoother. As you can see, the entities keep their distance between them from start to finish, and we reach maximum velocity around the 170 yards. Very good. So that does it for scaling difficulty. You can of course change these values to however you want. Okay, and for the second part we are gonna make some new logic to spawn our enemies. Right now our spawn logic is pretty simple, since we are only choosing in a 50-50 between booties or rocks. But as we add more creatures, we'll also have new things to care about, and things will get pretty messy in our spawn manager. So let's make a new class just to see what enemies should we spawn. And I'm gonna call it getMobManager. Okay, and in here we want the array of game objects that is spawn, and also the function that will return the game object that we want to spawn. So let's go to our spawn manager, and let's steal the entities prefab. Let's also go to the spawn entity function, and let's steal this bit of code. Back in the getMobManager, we want to make a new function that will return a game object, and I'm gonna call it getMob. We pass the code that we stole, and we just use the return keyword. Then, in our spawn manager, we want to call this function when we spawn an entity. To do that, we first need to make a singleton. Back to the spawn manager, and in here we call the function. Now this looks a bit silly, but trust me, we're gonna make the getMob manager a lot more complicated. Back in here we want to add two new values. A value that tells us how many enemies we have unlocked, and another value that tells us how many enemies we can unlock. These values don't need to be serialized, but we'll keep them serialized just to debug. In this function, instead of catching a random game object in an array, we'll cast a random number based on how many enemies we've unlocked. Although the first two enemies in our game object array are actually the booty and the rock, and these two entities are unlocked from the start. So we say that we want a random number that goes from 0 to 2 plus how many enemies we have unlocked. Just like so. So now, at the start of the game, even if we have 3 entities in our entities prefabs, we'll still only be able to spawn either a booty or a rock. We'll be able to spawn the third entity only if we value how many enemies unlocked is more than 0. So now let's make a new function to increase this value. And I'm gonna make it a public void called addEnemy. In here we just check if the current enemies unlocked are less than the max, and if yes, then we increase that value. Then we want to set the maximum values of enemies unlocked to be equal to our entities prefabs minus 2. Again, minus 2 is because the booty and the rock are already unlocked at the start. This way we don't have to change these two values in here. The maximum value will be set automatically, and how many enemies unlocked increases through this function right here. Of course, we still need a way to call this function, but first let's go to the inspector and test some things out. Let's go in our prefabs, let's select our getMob manager, and let's drag and drop our booty and our rock. Let's also make a duplicate of a rock to test how many enemies unlocked max works. Make sure that the duplicate is the third element. Let's hit play, and I've also disabled the boat so that I don't have to worry about rocks. And right now, as you can see, we only spawn booty or rock, but if I increase the how many enemies unlocked, and you can see that the max is set to 1 because we have an extra entity to unlock. If I set this value to 1, then we'll also be able to spawn rock 1, as you can see. Pretty good. Now to call the function addEnemy, I actually want to make a new class. A very short class for now, but it will expand later on. And I'm gonna call it unlockEnemiesManager. In here we want a condition to be met when we want to increase the difficulty of our game. In my case, in my game BoatVenture, I made the difficulty increase every 250 yards. To do that, we need to read the yards manager and check if the current yards are a certain amount. And if they are, we call the getMob managers function. So first I'm gonna make a float. And this is the amount of yards that we have to be added to increase the difficulty. And then in the update method, we'll just check if the current yards in our yards manager are equal to this value. Here's a problem though. We don't have a way to read this value. In our yards manager, you can see that yards travel are private. We could just make this public or make a new function to get this value. But while we are here, I want to explore properties, which is something we didn't look at in the previous episodes. You can of course skip to this timestamp if you already know what properties are. Properties are a way to have a value that is private in a set but public in the get. Basically, a way to have a value that it can be read from anywhere, but it can only be changed from inside the own script. This is very good because this way we can actually read the value from anywhere, but we don't have the random risk of manually setting it to a wrong value. And this is a syntax to use properties. To make properties, we set the value to be public, and then we say in between brackets, get private set. So this means that the get is equal to the actual value, so public, while the set is set to private, so it can only be set from inside this own script. but it can be publicly get. So let's go back to our unlock enemies manager, and now if you call the yards manager, we can see that now the value appears, but if we try to set it, you can see that it gives us an error. If you try to read from it though, you can see that it works because we are only reading from it. Okay, and for those of you who already knew what the properties are, this is the syntax right here, and this is what we have done in the unlock enemies manager. Okay, now let's actually cast this value into an int, so like this, and let's also change the yards we met with an int, and let's check if the two values coincide. And we'll call our get mob manager. Good. This way our difficulty will increase when we met this specific value, but in my case I want to increase the difficulty each time we hit a certain value. So instead of saying is it equal, we ask can it be divided by it with the rest of 0. Last thing though, this function is called onUpdate, so it will happen 60 times a second, and we're probably gonna be on the exact same yard for more than a frame. So what it means is that we'll call the addEnemy function more than once. To fix this, let's make a new int value. And we don't need this to be serialized. And now when we want to call the function, we check if the yards that we are right now are different from the previous times that we hit the function. So we just say if the current yards are different from the previous yards met. And finally, we add to the function by also setting the previous yards met to the current ones. Let's test this, and I'm gonna add another entity prefab just for debugging. I'm gonna set the mark to be 20 yards. So at the start we have 2 extra enemies that we can unlock. If I hit play, at 20 yards the enemies unlocked go to 1, and at 40 they go to 2. And if I keep going to 60, they'll still be 2. Perfect. And as you can see, we're also spawning rock 1 and rock 2, which are the 2 extra enemies to unlock. Very good, but rocks are kinda boring, so let's make a new enemy, and that will be an octopus. I'm gonna delete this, and I'm gonna open our rock 1, and I'm gonna call it an octopus. And I'm also gonna drag in 2 sprites that I already had prepared, one for the head and one for the tentacles. So for the main body, I'm gonna use the head. Change the collider a little bit. And for the entity type, I'm gonna just open it and add a new line of code. So I'm gonna say octopus as a new type of enemy. And while we're here, let's prepare in advance. I'm also gonna add the tentacle entity type. Back to Unity, let's change the entity type. And let's make a new child, and will be a 2D object, sprite. And I'm gonna set the image to our tentacle. I'm gonna resize it a bit. These are the values that I've put if you want to do the same. I'm also gonna add a box collider. 2D of course. And make sure to set it to isTrigger, just like the parent. I'm also gonna rename it. And I'm gonna add the entity type script to this tentacle as well. Let's also add the tag entity. And this mob has a child, as you can see. It's also gonna have another tentacle, so 2 children. And this can mess up our current script, so we need to do a quick fix right now. Let's go back to our spawn manager, and in our increase speed function, let's check if the entities that we want to move actually have a rigid body. In the case of our tentacles, they don't have a rigid body, they just follow the parent, so the octopus. So in here we just check if the entity has a rigid body component. Pretty good. By the way, when you have code that looks weird, you can just copy and paste it and it will automatically be put into the right place. Just like now, I can use Ctrl+C, Ctrl+V, and you can see that it goes right back in the right place. Okay, and the next thing that we have to fix is in our boat collision script. In here, instead of checking each entity what to do, we just want to know if the entity that we hit is a booty or not a booty. So instead of a switch statement, use an if. And if the entity that we hit is a booty, we just copy this code here. Otherwise, we'll just call the finish game manager. Back to Unity, let's go to our getMob manager, which is right here. And let's fix the array. And now as you can see, the octopus is the third element. And if we play the game, we're gonna unlock the octopus when we reach the 20 yards mark. As you can see, we can also collide with it and die if we hit it. But of course, there are two problems. The first one is that the octopus has to spawn at the center of the playground. The second problem is that this octopus only has one tentacle. And ideally, we want the octopus to have two tentacles, and when we spawn it, choose which one to spawn, randomly of course. So let's go to our getMob manager. And in here, when we return a game object to the spawn manager, we also want to tell the spawn manager if the entity that we want to spawn is an octopus or not. But right now we are already returning a game object. We also want to return a boolean that tells if the entity is an octopus or not. To do that, we use something called the out keyword. So basically, out is a way to return multiple values. In the parameter of the function, we just say out bool is octopus. And then, before we return, we want to set this value. Let's split this part of code in multiple lines. And now, before we return the game object, we check if it is an octopus, and if it is, we change the isOctopus to true. So we just get the component from the entity, and if it is an octopus from the entity type, we set the out value to true. And that's it. Now let's go back to our spawn manager. And in the spawn entity function, as you can see, now we have an error in the getMob function. That's because we have now to feed it a boolean. So I'm going to make a new boolean called isOctopus. And I'm going to feed it to the getMob function. And we also have to add the out keyword before the value. And we're done. Now whenever we want to get a mob from our getMob manager, we will also automatically know if the entity is an octopus or not. Now we just change the spawn position.x to be 0 if we are spawning an octopus. And we're good. Now we're only gonna spawn octopuses at the center of the screen. Okay, and the second problem is having a random tentacle to spawn whenever we choose an octopus. So let's go back to our octopus prefab, and let's make a duplicate for our left tentacle. Let's flip it. And let's make a new class for octopus called octopus entity to choose which tentacle to spawn when we spawn the octopus. In here we make a game object array for our tentacles. And we make a new public void choseTentacle function to choose which tentacle to spawn. In here we just take a random game object in an array and set that value to be true. Then in our inspector we'll disable both the tentacles so that this function will choose which one to show. Okay, let's go to Unity. And we disable the tentacles and we add them to the array. Now, the thing is, how do we call this function now? We could just use the boolean that tells us whether we are spawning an octopus or not, and if it is true, then we check if it has an octopus entity and we call the choose_tentacle function. But that is too much work, because if we want to add more enemies, then we'll have to make custom function for each enemy, and that is very inefficient. So what we want to do is actually something called class inheritance. If you already know what class inheritance is, skip to this timestamp. Class inheritance means having a class that derives from another class. By default, all classes that you make in Unity derive from monobehavior. And monobehavior makes it so that you can add classes like components, so you can put them into game object. But the cool thing is, you can derive from monobehavior and also from another class. And deriving from another class other than monobehavior gives you a lot of tools. Let's go back to octopus entity, and in here, instead of deriving from monobehavior, we'll derive from entity type. And because entity type is deriving from monobehavior, octopus entity still also derives from monobehavior, so we can still add this component to our game object. If you go back to the inspector, you can see that we are now inheriting all the values from entity type. In this case, the only values that we're inheriting is entity type. So let's remove entity type, and let's change the value here to octopus. And now this class acts exactly like entity type, but the cool thing is, we can now call an empty function in the entity type class and link it to the octopus entity. This way, our code won't actually change that much, and it will be a lot easier to add extra enemies and extra custom functions. So let's go to the entity type class, and let's make an empty function called start entity. Now let's go to our spawn manager, and when we have spawned an entity, let's call that start entity function. And now we'll link the start entity function to our octopus entity script. This way, when we're spawning a random entity like say a rock, then the start entity function will be completely empty and nothing happens. But if we're spawning an octopus, which has an octopus entity class, which derives from entity type, then by linking our functions, we'll make it so that the start entity will actually call the choose_tentacle function. And you can see how this makes things a lot easier, because we can now make as many different functions custom that we want, as many different enemies I want, but this bit of code will still be the same. So to link our functions, let's go to the entity type, and let's add a keyword in here called virtual. And virtual means that this function can be changed from other classes, or rather from child classes. In this case, the parent class is entity type, and the child class is octopus entity. So in here we say public, and the keyword to use is override. And as you can see, there are 4 functions that you can choose to change. The one that I want to change, of course, is start entity. Now, as soon as we write override, we're going to be set with a base.startEntity function. Base means the parent class, so entity type. Start entity means that we call the parent class start entity function. In this case, the entity type start entity function is empty, so base.startEntity won't do anything. So we can delete it. Now in here, we just call the choose_tentacle function. And that's it. We can now go back to Unity and test it in play. Okay, and this part is for those of you who already know what inheritance is. What we have done is inheriting from entity type with a new class octopus entity, and we've made these 2 new functions. This one is to choose which tentacle to spawn, and this one is the function to call from spawn manager, right here. In the octopus prefabs, we've set the 2 tentacles in an array, and we've also disabled them. Okay, so let's test it. And now we can see an octopus with a right tentacle, and one to the left. So I think we're good. Okay, and one last thing, I promise. I want to know when we are spawning an octopus, and if the last time we spawned something, that something also was an octopus. Because the thing is, I don't want 2 octopuses to spawn in a row. Now the game seems very easy, but as soon as we add more enemies and more interferences like wind or fog, having 2 octopuses spawn in a row with different tentacles is going to be very hard to maneuver. So let's go back to our getMob manager and add some new logic to see if the previous entity was an octopus, and if it was, and we are spawning an octopus right now, then remake the function. In here we want to add that logic. To make this new logic, we'll use a while loop. We'll move this value outside here, and the out value inside. We'll also move all this code inside 2. And now, after we have chosen an entity and we know that it's an octopus or not, we just check if the previous entity also was an octopus. So we need to make a new bool value. And by default it's false. In here we check if both isOctopus and previous spawn was octopus are true. And if so, we just continue. And the continue keyword makes it so that we continue the while loop, so we go back to square one. Else, if a previous spawn was not an octopus, but the one we are doing right now is an octopus, then we set previous spawn octopus to true. Otherwise, we set it to false. And finally, we break. And break means that we break from the while loop and we go forward with the code. And we reach this break code only if isOctopus and previous spawn octopus are not both true. Also, when you're using a while loop, be sure to be extra careful, because if you mess things up, you could break the game. The game, but also the computer, and have to restart it manually, which could also lose you a lot of progress. Trust me, I know by experience. Okay, let's test this in Unity. And as you can see, we are not ever spawning 2 octopuses in a row. Very good. So that's about it for this episode. I hope you've learned a lot. If you want to know how the finished product will look like, take a look at my game, BoatVenture, which you can find on the Play Store, link in the description. If you have any doubts or requests, tell me in the comments. In the next episode, we'll add a moving background, so it will look like we are actually traveling in the game. Please like and subscribe if you want more of this content, and I'll see you in the next video.